Welcome to Solemma's video tutorial on how to use ClimateStudio's radiation map workflow to perform a monthly and annual solar radiation analysis. Uses include identifying locations for solar panels or designing a static shading system. Click on the radiation map icon in the ClimateStudio toolbar to open the ClimateStudio Workflows tab. There are three input parameters: location, materials, and analysis surfaces. First, choose a climate file in the location input. Sun and sky radiances are derived from this file for the radiation calculation. Second, click on the materials input. We only have 2 layers in our site context that were pre-populated with LM83 defaults. Remember that objects on layers without an assigned material will not be considered in the simulation. Third, select the Analysis Surfaces input and click on the Add Analysis Surfaces button. I'm going to select both my buildings and my ground surface because I want a solar analysis on everything in my urban site. You can leave the default values as is, but note that our sensor grids are going to be more spaced out than those found in an indoor daylight availability study. For smaller surfaces such as windows or singular PV panels, you can adjust the sensor spacing to be smaller here. We are now ready to run the simulation. Navigate back to the ClimateStudio Workflows tab and press the Start button. The simulation works by using a progressive path tracing version of the radiance ray tracer. As more simulation passes are completed, you'll notice that the radiation map smooths out due to the larger number of rays traced to sample the urban scene. The simulation is now completed, and our urban site now shows cumulative irradiation values using a false color preview. Results are given in both graph and table form. Clicking on entries in the surface table will highlight the associated surface and update the statistics row at the bottom of the table. Deselect here. Hovering and clicking on a sensor will update the graph and information box directly above the graph with the surface name, sensor number, and solar exposure value in kilowatt-hours per meter squared. Click outside the model to deselect. Our graph shows total monthly solar exposure as is indicated in the first selection box. You can click here to view direct or indirect solar exposure. This will also update the simulation grids in your model, but you'll have to adjust the scale in the viewport display at the bottom of the results panel. Look at how my model changes when I update the scale's high value to 850. Results now fit within the scale range so we can understand them better. Now this is showing direct radiation, which is coming directly from the sun. Our other option, indirect radiation, is radiation from the sky dome plus reflected radiation, but I'll have to update my scale again to around 575 to get a better understanding. Let's go back to looking at total solar exposure for this tutorial, changing our scale back to 1450. In the temperature filter selection box, you can select to view results for all hours, warm hours, which are hours above 25 degrees Celsius, or cold hours, which are hours below 15 degrees Celsius. You'll have to update your scale again to see the results better. Here I'll change it to 250. Note that these results are not by season, such as winter or summer, but by hours in the climate file that are within the warm or cold temperature ranges. If you'd like to update the style of your graph, click on the hamburger icon here. Results can be exported by clicking on the rightmost CSV icon. Select if you want sensor metrics and/or surface metrics and press OK. If you need hourly data, you can run this simulation from Grasshopper. Let's take a quick look at our exported radiation map results. You can see that our results were exported as a variety of CSV files. For both sensor and surface, we have direct and indirect solar exposure for warm, cold, and all temperature hours. Clicking on Surface Direct Exposure, you'll find a table with our surface's area, annual direct exposure in kilowatt-hours per meter squared, and monthly solar exposure also in kilowatt-hours per meter squared. Thank you for watching, and happy simulations!